today we're doing learning target 7. Tomorrow we'll be doing learning target 8. You have work day on Monday, and you have a quiz over learning targets 5 through 8 on Tuesday. I'm going to keep saying these things, but... All right. Learning target 7 and 8, but 7 mostly. We're talking about double angle and half angle identities. Just like there's sum and difference identities, there are double angle and half angle identities. So I've already put them on your note sheet. You do not have to memorize. They are on the pre-calculus formula sheet. So, in the last section, learning target 5, you would have an angle like the cosine of 105. And 105 wasn't on the unit circle, and you had to find 2 angles you could add to get that angle, right? Or subtract. That worked wonderful, fine. Well, there's other angles that you're going to have that you can't add or subtract angles on the unit circle to get. So we use these other identities, okay? On these, you have to decide if you're using the positive or negative depending on what quadrant that angle is supposed to be in. So you have to think about those things before you start. Okay? Excellent. So there's 2 types of problems we're going to do today, some with half angle identities, some with double angle identities. Those are on the back. We'll get there in a second. So it says use a half angle identity, so it's telling you what to do to find the exact value of each function. So the first one is sine pi over 8. Again, fractions, not necessarily your forte. So we're going to change this to a degree measure. And you should get 22.5 degrees. Perfect example of why you can't find 2 angles on the unit circle to add up to get 22.5 degrees. Right? It's not going to happen. So we use the half angle identities. And if you notice in all those identities, it has alpha divided by 2. Right? This right here is not alpha. That's not what that is. That's not it. You're going to find the double of this angle, and that's going to be alpha, because that angle divided by 2 would be this. So what's 22.5 times 2? 45. So instead of finding the sine of 22.5, I can find the sine of 45 divided by 2. $45 divided by 2 is 22.5. So now I have something from the unit circle that I can use, and there's an identity for this. Right? Yes? What? Right, you multiply by 2 to get the number that's going to be on the unit circle for you. So here, 45. All right, so the identity back here. It says plus or minus, so let's think about this for a second. 22.5 degrees is the actual angle I'm trying to figure out, right? Is 22.5 degrees is in what quadrant? First, so sine is going to be, so I don't have to worry about the sign, that's awesome, right? It's going to be positive, there's no trickery putting a negative at the end, okay? So I have the square root of 1 minus cosine alpha divided by 2. So that's what I'm going to use. Again, now 45 is the alpha, not 22.5. So I have the square root of 1 minus cosine of 45 divided by 2. We already decided it was going to be positive. Everyone good so far? Okay. So we know what the cosine of 45 is. It's on the unit circle. So what's the cosine of 45? Excellent. I'm going to go ahead and find a common denominator in the numerator. That's not necessarily the next step you have to take, but that's what I'm going to do. So 1 is the same thing as 2 over 2. So you would have 2 minus the square root of 2 over 2. That's just the numerator, all divided by 2, the denominator. Everyone still with me? Yes? All right. In order to get rid of the fractions, I'm going to multiply by the reciprocal. The reciprocal is not 2 over 1. This is 2 over 1, so the reciprocal is 1/2. But that's a mistake some of you guys make, so I'm just making sure we are all on the same page. Okay. Everyone, any questions before I move on? Everyone's with me here. All right, so we're going to multiply. So I have 1 times 2 minus the square root of 2, so that's just 2 minus the square root of 2, over 4. Yes? All right, then we're going to go ahead and take the square root of the numerator and denominator separately, because you can do that, and we know the square root of 4 is 2, right? So I'm going to have the square root of 2 minus the square root of 2 over 4. Over 2, sorry. Good catch. Got ahead of myself. All right, so here is the exact answer. Yeah. Well, that's the square root of 2 in the numerator, and it's just 2 in the denominator. So those aren't equivalent. No, because again, the square root is only in the numerator. Sometimes. No, the numerator has a square root. This is the square root of 2, and the denominator is 2. Any questions on an example? Going once? Going twice? Can I erase this? All right, the next one. The tangent of 165 degrees. And it tells us to use a half angle identity. So I need to know what the double of 165 is so I can use the identity. So what's 165 times 2? 330. If I want to use this identity, I have to have some angle divided by 2 that's equal to 165. So if you multiply 165 by 2, then you have it. All right, yes, so 165 degrees is in what quadrant? 165 is in what quadrant? So that's the angle we're really trying to find, right? Not 330. So 165 is in quadrant 2, and tangent is positive or negative in quadrant 2. Negative. So you need to make a note, because at the end, you better have a negative on your answer. So some of you guys, if you started putting it at the beginning, you would forget it at some point through the steps. So you need to make a note so that at the end, you can put it somewhere. You don't have to. That's fine. Because again, if you do, generally people forget it eventually. They just leave it off. So just make a note and put it at the end. All right, so the half angle identity for tangent is the square root of 1 minus cosine alpha over 1 plus cosine alpha. So 1 minus the cosine of 330 over 1 plus the cosine of 330. Yes? What is the cosine of 330? Negative. Square root of 3 over 2. Cosine 330. Cosine is x. That's what the identity says. So you have 1 plus the square root of 3 over 2.
going to show you two acceptable ways of this problem. One will get you the answer from the textbook, and one will get you an equivalent answer, and it's also it just depends on what you would think to do first. It will just depend on what you would think to do first. Alright. In both of these, well, it depends. I'll do it two different ways, but one way, alright, is you're going to multiply by the conjugate. Yes. But the book, again, I didn't do it this way, and I had to go back and look to see why my answer didn't match theirs. It is equivalent. It's just not what they had. But they were clever. I'm not as clever sometimes. And they decided that since you have 1 minus the square root of 3 over 2 times 1 minus the square root of 3 over 2, they would just write that as 1 minus the square root of 3 over 2 squared since there's a square root, which makes sense. I just didn't think that through. That makes sense because there's a square root. I didn't think that through when I did it. It's fine. In the denominator, you still have to FOIL. So you get 1. It does. You'll see in a second. You get 1 minus the square root of 3 over 2 plus the square root of 3 over 2, and then minus 3 over 4. Everyone knows where the denominator came from. So these two terms cancel out. You get 1 minus 3/4, which is a fourth. At this point, they go ahead and take the square root of the numerator and denominator separately. So you have 1 minus the square root of 3 over 2 over 1/2. Right, the square root of 1/4 is 1/2. You could. And then they go back and multiply by the reciprocal. We're going to have to distribute. So you get 2 minus the square root of 3, right? Yes. And then you have to put the negative in the front. So then you would have this or negative 2 plus the square root of 3. They're both the same. You could have done that. I wasn't that clever. I didn't think to square the numerator, so I didn't do that. I just didn't think about that. I didn't think that was We decided at the very beginning of the problem, 165 is in the second quadrant, and tangent in the second quadrant is negative. So we just made sure we made a note to put it at the end. Okay, what I did, I'm not saying that it's any better than this. It just gives you a different answer. Okay? You don't have to write this down. You already have one. It's fine. Up here, where they multiply by the conjugate. Actually, you get the same answer doing two things here. You can multiply by the conjugate and do what I'm already to do, or you could find common denominator of the numerator and denominator and multiply by the reciprocal, yada yada. They will both yield the same answer here. That's not the one that they got down to the bottom of this page. So when I multiply by the conjugate, I went ahead and just FOILed the numerator too. Again, not that clever sometimes. So I got 1 minus the square root of 3 over 2 minus the square root of 3 over 2 plus 3/4 in the numerator. I'm going to go ahead and have 1/4 in the denominator. We already saw where that came from. So then I get 1 minus 2 square root of 3 over 2 plus 3/4. Those 2's cancel out. 1 plus 3/4 is 7/4 minus the square root of 3. I'm just doing it the way I did it, so you can see there's different answers. Multiply by 4/1. So you get 7 minus 4 square roots of 3. That's equivalent. It's just not what it will look like otherwise. We did in the last question. So if you go ahead and FOIL it out, it's not wrong. You're just going to be getting a different form of the answer. So I want you to not freak out every time you look at my answers and you have something that's not, doesn't look the exact same. You can always type these in the calculator to make sure that they're equal, right? Yes, it would still be negative. Questions on those? So if you're using a half angle identity, you're given an angle measure. You're going to double it so that you can use the half angle identity where it has something divided by 2. And then simplify to find an answer. Still using, again, you're using an identity as the guide, what you're doing. Questions? All right, then on the back. There's also such thing as double angle identities. You have only one of the cosine ones because the one I put on your note sheet is the one that's on the pre-calculus formula sheet. So even though there are 3 double angle identities for cosine, only one of them is provided to you, so you need to be able to use that one, which generally is not a problem. The others aren't provided to you on the formula sheet. So if you want to know the others, you have to memorize the others. If not, you need to use the one on the top. Yes. All right. On the problems on the back, it's going to tell you to find all 3 of these: sine of 2 theta, cosine 2 theta, and tangent 2 theta for each angle measure. It'll be fine. I promise. Okay, so the first one, I've got sine theta equals 2/5. That means I don't know the angle measure, right? Theta is the angle measure. I don't know what it is. All right, but it wants me to find sine 2 theta, cosine 2 theta, tangent 2 theta. So we're going to use these identities to figure those things out. So first of all, sine 2 theta is the first one. And the identity says 2 times the sine of theta times the cosine of theta. Well, I've got sine theta, but I don't have cosine theta. All right. We don't have cosine theta. We have done enough of these problems, though. You guys should know how to find cosine theta. So how are you going to find cosine theta? Right, sine squared plus cosine squared equals 1, so cosine squared equals 1 minus sine squared, and we're going to solve to find cosine. So I have 1 minus 2/5 squared. Again, I show all my steps, people won't get confused. If you skip a few steps, it's not the end of the world. Minus 4/25. 25/25 minus 4/25 is 21/25. And then we take the square root. So cosine theta equals the square root of 21 over 5. All right, so now I can actually do this identity. So sine of 2 theta equals 2 times sine theta times cosine theta. So that's 4 square roots of 21 over 25, which is the answer. So I have this identity. I already had sine. I found cosine. I substituted those into the identity and multiplied. Questions? It also tells you to find cosine 2 theta and tangent 2 theta. So cosine 2 theta equals cosine squared theta minus sine squared theta. You already have the pieces, you just substitute them in. So the square root of 21 over 5 squared minus 2/5 squared. Yes, you could. So if you already had this part up here, you've done your work, you could just put that in. It's the same thing. All right, so we end up getting 21 over 25 minus 4 over 25. Over 25. That's sine 2 theta. I'm finding cosine 2 theta and tangent 2 theta. For tangent 2 theta, you have 2 tangent theta over 1 minus tangent squared theta. That means you need tangent theta. Tangent theta is sine over cosine. Sine is 2/5. Cosine is the square root of 21 over 5. Since you're using this in the problem, you don't have to rationalize it. I just have to find tangent theta before I even do anything. So I'm finding tangent theta before I do anything. Right. So in order to do tangent 2 theta, I have to find tangent theta first, because that's what's part of the identity. So I took sine divided by cosine and found it. Again, you don't have to rationalize because you're going to use it in the question. Right, so let me plug it in. So we've got 2 times 2 over the square root of 21 over 1 minus 2 over the square root of 21 squared. So that's 4 over the square root of 21. And then 1 minus 4 over 21. So you have 4 over the square root of 21. 21 minus 4 is 17, so 17 over 21. Multiply by the reciprocal. I'm going to leave it like that for a second. I need to rationalize the denominator. I didn't separate anything out because I'm going to rationalize. If you multiply by the square root of 21, this is why I didn't write anything out multiply, because the 21s cancel out. So you get 4 square root of 21 over 17.
other one, I won't take time to do it, but if you have tangent, you're going to have to find sine and cosine at some point. So I would probably use either tangent squared theta plus 1 equals secant squared theta. No, again, you guys know the tangent is sine over cosine, but we just did a problem where we divided things out and things canceled out. So you cannot use that logic. Sine is not 4, cosine is not 3. So you need to use one of these identities to figure out secant or cosecant, so that you would have the reciprocal and find sine or cosine. So you know sine theta and cosine theta. On this one, theta is in the third quadrant, so sine theta is negative and cosine theta is negative. I think that would. Say that one more time. Cotangent would be 3 over 4 yes. Alright, so you have the rest of class today to do 1, 2, 3, 5, 6, or 7. Some of you guys haven't started, I'm concerned.